In this video, we are going to learn about horizontal and vertical coordination of geometric design. So far, we have learned up to 7 steps from an introduction to vertical alignment. So this will be the final step of geometric design we learn, that is horizontal and vertical coordination. So when you are designing, these theories and all those things are derived from research and empirical formulas and by engineering theories. But when you are applying this to an actual roadway, you have to think beyond the theory and research or empirical formulas and apply what is suitable for the scenario. So otherwise you won't be having a efficient or smooth flowing roads or highways. To do that, we have general controls for horizontal alignment, vertical alignment, as well as both horizontal and vertical alignment. In this section, we are looking at the general controls for horizontal alignment. One thing we have to consider is your alignment or the road should follow the natural terrain as far as possible. In this left side image you can see this is a hilly road, but the road is coming on the contour, so it is following the natural terrain. Then we have to avoid as much as shorter curves. We should not use shorter curves in designing the horizontal alignment. Shorter curves makes driving uncomfortable. Here in this right side image you can see there is a very short curve, a sharp short curve, so the drivers would not feel comfortable when driving these short curves, so we have to avoid them as much as possible. Then when you are designing, you might remember in the super elevation lecture we have learned the minimum radius for a curve according to the design speed. So there were tables according to various design speed, how much of radius we have to use according to super elevation. For example, if you are designing a curve to 30 kilometers per hour design speed, so to have super elevation of 2.5, you should have minimum radius of 35. That does not mean you should always use 35 meter. You have to use higher radius as much as possible if there is room or if there is space for design. So in that location, instead of a 35 meter radius curve, if you can have 50 meter radius curve, you have to put that radius, because that makes the driver more comfortable in driving in that section. So you have to use desirable radius instead of the minimum radius, the absolute minimum radius. You have to use a desirable radius which is larger than the minimum radius. Then you have to avoid sharp curves at the end of long straight sections. In this top image you may see this is a long straight section. All of a sudden you will be coming on a sharp curve, so this kind of curves might be very dangerous in the night time, because when the vehicles comes from this side, he may not see the curve at once, so accidents may be very frequent at this type of location, so you have to avoid them as much as possible. Then you have to use a sufficient horizontal curve length to avoid the view of a kink. So it says you have to at least use 3V for your horizontal curve length. 3V means if your design speed is 100 kilometers per hour, so your curve length should be at least 300 meters, like that. So that is how to use the curve length, but that should be the least value. The desirable value would be 6V. So if your design speed is 100 kilometers per hour, your desirable curve length would be 6V. That should be 600 meters. So if you have shorter curve lengths, you can see this is a very unpleasant view of the road. We call it a kink. So to avoid the shorter horizontal curves, we have to use sufficient length of curve. Then when using compound curves, that means curves which going on the same direction without a tangent. So when you are using that kind of curve, the radius ratio should be R1 equals 1.5 R2. That means the larger radius curve should be equal or less than 1.5 times the sharper radius curve. Then you have to avoid broken back curves as much as possible. Broken back curves means two curves rotating in the same direction with a small short tangent or small straight section in between. So we have to avoid that broken back curves as much as possible, because when there's a straight section after the curve, driver feels that there's a straight portion. So in that straight portion he might increase the speed, but all of a sudden he will come across another curve. So that might be undesirable for the driver, or he might face unexpected conditions due to this curve behavior. Then we will be looking at the general controls for vertical curves, vertical alignment actually. So as I said earlier, the gradients and the vertical curve should be used to fit the natural terrain, but in doing so you should not make the road with the roller coaster effect. So in this case you can see this road is looking like following the natural terrain, but this is kind of a roller coaster road. So you can, if you are here, you may not see a vehicle coming in this sag curve. So this is called the roller coaster effect. So you have to avoid that effect when designing the road, when you are following the natural terrain. So instead of that, you have to use suitable method to avoid that effect and follow the natural terrain. Then sag vertical curves should be avoided in cut sections. If you can remember a sag vertical curve, which is a curve like this. So in sag vertical curves, the water is collected at the center. So if you have a cut section, that means the road is going through a mountain, or we have to cut the road you have to cut the existing ground to create the new road. So in that sense, there will be a section where the water is collecting at the center of the curve. Since there is a cut section, you have to put more effort to remove the water out of the cut section, because if there is a fill section, water will automatically drain out through the fill section, because road is at a higher level and the natural ground is at a lower level. But in a cut section, what would happen is the road is at a lower level, then the natural ground is at a higher level, so it is hard to drain out the water. So you have to avoid sag vertical curves in cut sections. Then two vertical curves in same direction. separated by a short tangent which is called broken back grade line should be avoided, especially sag curves due to aesthetic conditions. So I think you could understand this thing. So two vertical curves separated by a short tangent. So I explained the behavior in the horizontal alignment, which is meant by the broken back horizontal curve. So same thing happens here, broken back grade lines. You have two vertical curves with a short tangent in between, especially in sections. It will be very hard, or it will be very unpleasant view due to this broken back grade line effect. So then we will be looking at the combination of this horizontal and vertical alignment. Initially, in the initial part of this lecture, we looked about the horizontal and vertical control by individual sense, horizontal only and vertical only. But in this, now we are looking at both of them together. So how can we use both horizontal and vertical alignment together to have a better driving, comfortable and better safety and better road in our design perspective? So Ashto Green Book 2018 gives some examples of horizontal and vertical. This HA and VA means horizontal alignment and vertical alignment coordination in design. Ashto Green Book means that is a design guideline used or developed in USA. So this 2018 version is the most recent version. It gives some examples of horizontal and vertical alignment coordination. So you have other versions of this book also. At those books also we have the same examples. So these are some of the examples you have to follow in horizontal and vertical alignment to have a better coordination. So in this you have to note that in America the driving direction is opposite from ours. So they are driving this way on the left side of the road and this way on the right side of the road. So in Sri Lanka we are going the other way. Apart from that, we have all those things have to be followed as it is when you are designing. So if you have a straight section here, what it describes is you should not have a crest curve and a sag curve like this when you are designing. Instead, you can have a straight tangent section in the profile also in your plan, or in the horizontal alignment. If you have a tangent section, you can have a tangent section in vertical profile also. Here it says if you have a curve, you should not have bumps in your profile like crest, sag, crest. So you should not use this kind of behavior on your profile if you have a plan curve on your horizontal alignment. So if your horizontal alignment is a curve, your vertical alignment should not be like this. Instead, you can have the vertical profile some kind of a grid. Then you have this thing. You have a curve here and you have a straight here in your horizontal alignment. Here you have in the profile you have a lower ground here and a high ground here. So if you have vertical curves like this as this in the initial example like this, so the vehicles coming from this side, according to this image, the vehicles are coming from this side, so it will make an unpleasant bumps on the road if you design the profile like this. So instead you can have single grade. Here you have a short tangent in between the horizontal curves. This is a reverse curve separated by a short tangent. So this is not desirable for two reasons. That is, this tangent is too short and this reverse curve occurs on a crest. So this crest, the crest is the top point. So at the top point, the gradient is very low, it is close to zero. Here the gradient is somewhat higher, this side also somewhat higher. Here the gradient is very low. So there is a tendency to collect water at this point, and if you have a reverse curve, there will be a level ground area, you call it, where there will be a level road, because this, due to this curve, the super elevation occurs, or the water flows this side. According to this super elevation, according to this curve, water flows this side. So the road is turning this side here and turning this side here. So this road have to rotate to the other side in this area. So in this area, you may have a lower gradient road or lower super elevation road. Especially you will have a zero super elevation here. So here you have the zero super elevation, you have the zero gradient. So there is a very high tendency to collect water in this area. So accident may be very frequent in these areas if you design the horizontal alignment and vertical alignment like this. Then also we have another scenario where you have a shorter sag curve, smaller sag curve with a sharp horizontal curve. So this arrangement make this horizontal curve more sharper. So instead you can have a crest curve with a long curve with a long crest curve. Also you can have long sag curve as well. Both these are okay without this one. It has a sharper curve and a smaller, very shorter sag curve. The length of the curve is very low. So there are some other scenarios also. You can watch them, you can see them and learn them by yourself. Then I will be showing you a small video of what we have discussed so far.